Hello everyone. Today I'm with Sarah. She has a PhD in biomedical engineering, and she's doing also a research.
Hello everyone. My name is Sarah, as mentioned, and I'm currently doing my PhD at the University of Calgary in Alberta, Canada, and in biomedical engineering, but our lab specifically focuses on AI applications for medical imaging. And my research and kind of what I've been doing the past 2 years and what I will be doing for the next 2 years is dementia focused and trying to develop what we call computer aided diagnostic tools. And so these are using AI, but it's a subset of AI really. It's called machine learning. And machine learning, we are basically training computers for a specific task. So it's less open-ended, it's less, I would say, broad than your large language models like ChatGPT or Copilot that are like becoming really big things in society right now. We don't really work with models like that. We work with models where we're trained on one specific task. So for a very simple example would be like trying to differentiate a dog from a cat in an image, stuff like that. And so we use those techniques, use these machine learning models in the medical domain. Examples of my research specifically, since I work with dementia, I try and develop predictive models. So people in the early stages of cognitive impairment, I try and predict if they're going to develop later stage Alzheimer's disease or do a sort of classification approach to differentiate different types of dementia, all stuff like that. We're basically taking classic AI applications that have been around for a few years now and just applying them in the medical domain. In terms of where we're at and how this is actually going to be applied in the clinic and not just the research phase, I think we're still a few years out from that in Canada. The US has started to implement a lot of similar models that we develop in our lab. The US has already developed or implemented them in clinic. And I think it is a good thing that we want to move toward in the future here. We just have more regulations when it comes to kind of accepting these models. But we're currently, I would say, mostly around like 70-80% accuracy, and so there's still good tools to be using in the clinic. It's not perfect, but some of the decisions clinicians are making right now are at chance level 50-50. So even if we can improve that in any way, that's kind of what we're striving to do, and that's what I'm really passionate about doing in the future. But we'll see where it goes. I'm loving it.
So you'll be working for a company, for the university or for the hospital, or you'll be doing your own company for yourself, you'll be self-employed?
I would like my own company. We've started already, a few people in my lab, we've started to ponder ideas about where we can go with this. Currently we're just doing consulting, so open-ended tasks, but I think eventually we want to hone in on a product and actually choose a product to develop that we can then implement in whether it's cancer centers or clinics across Canada. That's kind of the goal. I just don't know exactly the specifics of what product we're going to be developing yet.